In a group of 25 students, 18 take chemistry, 12 take physics, 3 students take neither chemistry nor physics. The Venn diagram shows the events. C is studying chemistry, P is studying physics, and then the value of P, Q, R, and S represent the number of the students. So first is find the value of S. So S would refer to the 3 students that take neither chemistry 3. All right. Then we got 18 in chemistry, 12 in physics, and we don't know how many take both. So we're just going to use R as our variable. And so this part right here would equal, let's see, that is chemistry. So that would be 18 take away R. And over here for physics, we've got 12. So that Q is going to equal 12 take away R. So now to find the value of R, we know that these 4 items here have to make up all 25 students. So I just set up my equation. 18 take away R plus R, 12 subtract R plus 3 is equal to 25, and now solve that. All right, now that we got R, we can fill in our values here. So the intersection is 8. 18 minus 8, P would equal 10. 12 minus 8, Q is going to equal 4. All right, so now we got our values for P and Q. All right, a student is selected at random from the group. Given that the student studies chemistry, write down the probability they study physics. All right, so what that tells us, so the way I'm going to write that out, it's given the student studies chemistry. So this would be the probability. So the probability here of P given C, what that does is that says that the student is a chemistry student. So what we're going to do is take our Venn diagram, and the only thing we're going to look at is the chemistry portion of the Venn diagram. Okay. Now from that we can see that there are 18 students together in chemistry, and then the portion of those students that are also taking physics is this little overlap right here. Those are your physics students. So that tells me that I have 8 out of 18, which would be 4 out of 9. Okay, now that's doing the problem using a Venn diagram. You could also use the formula for conditional probability, which says do the intersection of P and Q, or P and C. So I would do the probability of P and divided by the probability of chemistry. All right, and the way that that would work out now would be, let's see, the probability of the intersection is 8 out of 25 students. So my numerator would be 8 out of 25. And my denominator, chemistry, is 18 out of 25. And then when you simplify that, so either way, you can do it using the formula or you can do it using the Venn diagram. Okay, the next part of the question says, hence, show that studying chemistry and physics are not independent. Well, when you see the word hence, that tells you to use the previous results to answer this question. All right. So to show that 2 figures or 2 events or outcomes are not independent. Okay. So to be independent, we'd have to show either that the intersection is equal to the product, or the conditional probability statement right here holds true when we plug in the values. So I took these two right here and I wrote it up here. Does this hold true? So either the top statement, which is the intersection method, or the statement on the left, which is the conditional statement method. Since this said hence, I would guess that we're going to use the conditional method because that's what we calculated right here in part 1. So what I'm going to do is I want to know if I take that out and I put in 4/9, does that hold true? Is that the same as the probability of physics? Well, the probability of physics, there's 12 physics students. So this part would be 12 out of 25. Okay, and those are not equal. So this does not hold true. Put does not equal, therefore P and C are not independent. All right, 2 students are selected at random, one after the other. So that's important because that's going to change the number of students that you're picking from. All right. What's the probability that the first student studies only chemistry and the second student studies only physics? So when we look at this graph, our Venn diagram here, only chemistry makes up 10 of the 25 students. So this is 10 over 25. And we're going to multiply. However, the physics students are not going to be 4 out of 25. Rather, it's going to be 4 out of 24 because you've already chosen one student because it's one after the other. So now there's only a pool of 24 students to pick from. So I multiply that out and get 40 over 600, which reduces to 1 out of 15. And that is my probability.